So now we'll look at some motor physiology, which is movement. Movement is simply, or behavior, is a series of muscle contractions, and we have cardiac muscles, we have the smooth muscles and intestinal organs. What we'll look at is the skeletal muscles. That's what we're interested in. That's what I'll cover. That's how we move. We move with arms, legs, and our head, or facial expression, the dexterity, the lips, the vocalization of speech, and the tongue, the lip movement, and so on, and the facial expression, and the hand, the dexterity of the hand. I mean, that is highly studied in motor neuroscience, and again, it's controlled. We have many muscles in the hand and the face, and it's controlled by the brain. I'm not going to cover the physiology of muscles. I'll talk about the neural control of muscles. Neuroscience. So we have many experiments in electrophysiology on this. You can read more about these, Google these terms here. And as I've said previously in this video and in previous videos, yes, we'll look at the different parts of the brain that are responsible, in that case, for motor commands. We have the frontal cortical areas and the premotor, the primary somatomotor area. And at that, here what we have is the planning of movements based on sensory feedback and cognitive processes. And then you have and then you have the motor commands, which are sent to actually execute the planned actions. And we'll see actually that the planned actions, because there's constant feedback, and when you send the program, when you send the command for an action, it doesn't always end up to be the action you've sent the command for, and there needs to be constant feedback to correct for the discrepancies. It can get pretty complicated, but for A level, I mean, that's that's the gist of it. So different parts of the spinal cord are responsible. Higher vertebrae, we control upper limbs, and then you can see the legs, that would be the lower parts of the spinal cord, which makes sense, right? As I said before, one thing that's highly studied is the dexterity of the hand and muscle fingers. And here in the diagram you see, it shows the brain areas. You can see the sensory and the frontal information that's integrated in the motor systems, in the cerebral cortex and in the brainstem. Cerebellum is very important as well in posture, and also I think in learning, like things like walking, writing, things you don't really think about, right? You're not consciously aware of them unless you intentionally think about these things. Here we have some people which you should know. Born people, Charrington, who's a classic guy, did work on it. Kandel, Frith, Schwartz, and the Blakemore, Hagar, Rothwell, Mason, Lemon. Lots of people at University College London, where I went. UCL is a fantastic university in terms of its research, especially in neuroscience. And there's been work in the past 10 years or so there's been a lot of breakthrough work, and I definitely recommend go on the UCL website, look at the research there. It's pretty great.